Meet our first Amiga 500 board that we're going to refurbish. This one is, his name is Baron, and I don't really see any problems other than some evidence of spider population. There's definitely a little nest here. I'm just dry brushing things for now to see what might come off. I could just plug the chips. I could just plug the chips in here and give it a go before I clean it, but you know, I kind of want to clean it off and blow it out with compressed air just to make sure that there's no surprises, like a solder ball or something, or a piece of something that might short something out. Plus, I think I'll probably just take my multimeter on the floppy drive rails. I think there's a +12 and +5 there. Or I could do it on the connector, I guess. That's got all three. And just make sure that there's not a low ohmage issue between. Just so we don't potentially cause a problem with our power supply. Have a look at the other side here. Yeah, pretty sure I don't need to do anything here. I'm just gonna lightly brush it off. Yeah. And in general, there's nothing visual that should keep this board from working. I'm just gonna blow it out with some compressed air, and then we'll test it. Okay, so got everything in the shot right now. Okay, so we've got ground connected from the multimeter to shield, and we're just going to test this here. This one here is the +12. Got nothing. Okay, that's good. Let's just test. Yeah, okay, so we're on the shield and it's 0 ohms, or close to it. This center pin here is 12, -12 that is. And over here is +5. Everything's normal there. We don't have any dead shorts. We're not going to blow anything. We plug it in. So I guess that's what we can do now. Okay, fellers, moment of truth. Green screen. Green screen of death. Okay, so after switching various chips out, Baron doesn't seem to be any better. I decided to get a little smarter and use DiagROM. I have another video on my channel about the DiagROM. Here was the result of that video. It's a switch. The DiagROM's actually encased in this plastic box because I needed to put a switch on there so I could use this DiagROM on different Amigas. This is a release 6 Amiga, so I was able to flip it over to the release 6 position. And it's very interesting. I'll show on my computer screen what happened when I booted up DiagROM. But basically, I've only have a green screen, and when I put DiagROM in and booted up, I got something different. I'll show that now. Okay, shot of the computer screen. I'll just turn it on. Now flashing is a normal thing from DiagROM. However, the type of flashing that happens is indicative of the problem. So according to what I could gather on the internet, this particular sequence that's happening, where it's a whole 20 seconds or so of that and then this, indicates that there's definitely a chip mem problem. So but this isn't actually loading up DiagROM, and I'm not actually getting any kind of display. This is literally the direct output of the Amiga. So what you need to do, or what I did in this case, is I needed to hook up the serial connector from the Amiga, because even though we're not seeing anything on the screen, we could be seeing an output of the serial port. So you need a USB to serial, like a prolific USB to serial adapter, so that you can add serial port to a newer computer. If you have an older computer, you can just go ahead and use that, and then use a program like PuTTY or HyperTerminal or whatever to have just any kind of terminal program that'll run in Windows or whatever operating system you're running on your desktop or laptop or whatever other computer you have. But basically what you need is a Null modem serial cable that's got females on both sides. One side's going to be a female that has a 9-pin, and the other side's going to be female with a 25-pin. Okay, so I'm going to use PuTTY as my terminal program. We just need to set it to a serial connection. And in this case, my prolific is set up on serial port 7. And that's pretty much all we need to do. 9600 baud is correct. So here we have an open terminal window. I'm just going to power on the Amiga. Okay, so right now I'm just getting flashes on my Amiga screen, but I get to see a lot more information. I believe, yeah, it's testing every bit of memory, and it really doesn't see any of it. It takes about 20 seconds or so for this to, okay, there we go. So it didn't find any memory at all, and you know, without any memory, the DiagROM isn't even going to work. So I have discovered another thing, so we'll move to that subject in a second. So I had assumed that this is a garden variety A500 motherboard release 6 with the 8370 half of meg of chip RAM. However, after doing some research about memory and finding the inevitable modifications, I was reminded that there is a modification you can make to an Amiga 500 motherboard, a release 6 or newer, that's fairly easy to make it have a megabyte of chip RAM. And the first part involves cutting open J7. And as we see on this motherboard, if I focus in, JP7 is indeed cut. So that probably means that I need to be using a 8372 Agnes. We'll check the JP2 as well to see if it that should be cut as well, and a solder blob added to the other two pins. And yeah, it looks like that's been done here as well. It's right next to the it's right above the ROM chip on these, if I can get a good shot of it here. So as you can see, there's a cut made right there, and that a solder blob has been added here. So the next thing we should probably do is test this with a 8372 Agnes and an expansion RAM installed into the expansion trapdoor memory spot. Okay, so here we have PuTTY opened up again. We got connection to the Amiga again. I'm going to go ahead and power it on. Okay, so we still have a lot of failed memory, but you'll see at the end that it actually proceeds. And what I get is a menu now. So let me move the other mouse out of the way. Okay, so now I've got this actually working, and we can proceed with memory testing. The detected chip mem, I'm not sure what's going on there, but it seems to freeze, or maybe I'm not patient enough. Anyway, so we'll test the extended chip mem, and we see we've got problems. So even though we have discovered the correct configuration of our Amiga at this point, we still have some bad memory on board somewhere. So I think what the best course of action would be to revert this motherboard back to its default setting of having 512K of chip RAM, and then we can do some further diagnosing, because I'm not sure what I'm actually looking at here on this screen. And you know, I don't know if the trapdoor memory is going to be properly detected or tested or whatever. So I'm going to revert. I'm going to change those two jumpers back to the way they were and put a regular 8370 in there, and we'll see how we do. Okay, so here we have PuTTY up again. We're going to turn the computer on. So basically what I did is I moved those two jumpers over to their default positions, put an 8370 back in, and I got the same problem as though I hadn't done it. And you know, with the 8370, you know, the 512 Agnes and the trapdoor memory not installed, I got the same exact thing. So I think what's happening is the program DiagROM won't complete its loading because there's no memory available. So I decided to just throw the trapdoor memory in there, and now it seems like it will load. Although what's happening is I'm not able to use it on the Amiga. I'm only able to use it on the this serial connection. But it's interesting. So basically the 512K of RAM on the motherboard is essentially useless, inaccessible. The only difference with me making that modification is that that I have slow RAM available to me instead of chip RAM. So yeah. All right, well anyway, so I'm going to proceed to try to diagnose this. First thing I did was take a look at the A500 R6 schematics. A really annoying thing was that the processor and Agnes were on one page and the memory was on another, so I felt compelled to edit the pictures and combine them. And as long as I was at it, I can add colored data path and address paths to the image. I just wanted to make it easier to read and remember which logic chips are doing what. The information for testing individual pins is carried over from the schematics, so this is my primary tool when I want to test signals. This image is available on my website, retrofriends.com. And as we can see, I've used red for the data path and green and blue for the addressing. The address inputs would be green and the column and row enables are these blue. And we can see the two U34 and U35 logic chips that are down by the memory. So as many have suggested, I started testing voltages first. The memory chips, the address logic, the data path chips. However, if you look closely on the schematic, there's no indication of VCC on the chips themselves. There's no VCC here, here. Here's the memory chips. These are the ones that are actually used in a default configuration. These are the ones that are blank on a release 6 and above Amiga 500 motherboard. I forgot to put little green lines across there. Sorry. Anyway, so if you need to know the voltages, you're going to where the voltage pin is, you're going to have to bring up the specific data sheet from the actual chip itself. So here's a RAM chip 20-pin DIP RAM chip for 256. And you can see that VCC is on pin 10. So I did that for the memory chips and the logic chips, looked them all up, got the VCCs, tested them out, and everything seemed fine. And using the same methodology of looking up the chips on their signals, the address lines and the data lines, I tested those with an oscilloscope, and there are signals. Basically, as long as, I believe, if I'm not mistaken, as long as you test all that stuff on the actual RAM chips, it means that they are receiving the data. Now, is the data correct? No. In order to tell that, you'd have to use a logic analyzer and know a little bit more about programming. But you can just see if the chips themselves are receiving the data and the addressing information. And as it turns out, all of the RAM chips are receiving that information. So I decided to take a little break, step away from it. It was Christmas time anyway, so I just stepped away from this project for a day, and randomly I was just thinking about it, and I was thinking, well, what's the commonality between the external memory and the onboard chip memory? And so the external memory is plugged in and going right into these data path logic chips. And also the chip memory is going through them. But however, the external memory, the trapdoor memory, is actually working. So that kind of tells me that these 4 chips are actually good, at least partially, because they seem to be able to address the memory that's on the expansion. So I kind of ruled these 4 logic chips out as being a problem. So that leaves us down here. And so we either have these as a problem, or we have the actual RAM chips themselves. So then what I did is I sort of rationalized, well, these are sending signals to the RAM chips. So these are probably working. Either that or they're just not sending correct signals. Maybe they're just sending signals that are too weak or too strong. But I could see all of the signals from these chips going into the RAM with my oscilloscope. So I decided to use the standard method that a lot of people use, by piggybacking RAM onto the RAM chips. Okay, so here we have the RAM chips piggybacked, all 4 of them. And we're just going to turn it on. And we're going to see what happens. Just green flashing. And we can see what's happening on the serial port over here. But as we can see, this is probably going to work. I think it is working. We don't have all those failed chips. It boots up a lot faster. And I think we're good. So now the question is are they all bad? Or are some of them bad? So we're going to turn it off. We're going to pull that one off. Yeah, so it looks like that's good too. So we got 2 bad mem chips. And that is what's wrong with Baron. Not too bad, Baron. Oops, this is Baron. I got a GoTech on him, loaded with Amiga test kit, formerly known as SysTest. In order to test as many peripherals as I can, I got them all plugged in. I've got a keyboard, a mouse, a joystick. Yeah, so let's turn this baby on. See, we're on right now, and we're loading. There we go. Make sure, okay. So anyway, let's just do a memory test. And I just did this particular test a while ago, and it just goes forever, I guess. And it doesn't, I think if there's any errors, they're reported here. Anyway, so let's escape from that. And let's do a keyboard test. Yeah, I don't see any problems here. There we go. The floppy drive, well, I'm pretty sure we know that works. Mouse, joystick, and keep gamepad. Joystick. Only got one button on the joystick. And let's go do a sound, an audio. Indeed, that is correct. Actually, I just happen to have them plugged in correctly too, because that's left, right, right, left. Yeah, I think we're good. The video, I guess that's just testing all the raster. Oh, CIA, probably my favorite test here. Yeah, so tests all the CIAs as far as timing, using a timing. Anyway, I know the serial and parallel tests are going to be requiring those dongles, loop back adapters, or loop back, loop to signal back so that it's sending and then receiving, and then it's working. Anyway, so I think we're good. I think we definitely have a fully functional Amiga 500 Release 6 motherboard.
Hope that's a machine and not a fart.